Hi, Dave.
Hi, Piglin.
Yeah. And I sent you and Mike an email about confidential computing. I hope you received that.
Yep.
Okay, thank you.
I saw Mike responded, right?
Okay. It seems that people are still in vacation.
Yeah, I'm just looking back at your email now. The TAC mailing list is open, meaning anybody can join it. And so if you're not on it right now, then you can absolutely get on it. There's a difference between the attendees of the meeting, the mailing list, and the members of the TAC, right?
Yes,
The meetings and the mailing list are not just for members, they're for, they're public meetings, so anybody can attend. Membership is based on companies joining the CCC.
yes. Yeah,
But the meetings and mailing lists are for individuals, and yeah, you should be on both.
Okay. I used to try to convince my boss to join the confidential computing consortium, but
Gotcha.
I think I failed.
Yeah, but you can come to all the meetings and be on the mailing list regardless. So
Okay.
And if you're not on there right now, I can, unless Ashley gets on here, let me look up the link to subscribe here.
Okay. It seems I'm in there.
Are you on the list?
I think so.
Did you get the agenda mail from Ashley?
Yes.
Okay, then you're on the list.
Yeah.
Hello, Dave. Hello, Pingling.
Hi, Nick.
How are you folks? Happy New Year.
Happy New Year.
Happy New Year. I just got my COVID booster, so I am still feeling the side effects of that.
Well, congratulations.
Yeah, thanks. I think.
I got my COVID booster the same time I got the shingles, and it really knocked me down, the shingles vaccine. So 2 at once was a interesting choice.
Yeah, I got my flu shot, annual flu shot early December, and so I was waiting after that. So, and then of course here in Washington we had a whole bunch of snow and everything was closed down and all that kind of stuff. So anyway, I finally got in.
Hi folks, can you hear me?
Yep, I'm Mike.
Hi, how you doing, Dave?
Good.
And everyone.
Your mic is a bit loud, meaning there's a little bit of distortion.
Is that any better?
Yes.
Cool. It's usually a bit quiet, so sorry.
So Ashley, I've not yet seen either of our topic presenters joining yet. Would you mind sending a piece of email to ping them? I don't remember who the presenter is for the project, but Rosario can only make it during the first hour, and so I moved that up. I think Rosario has another meeting to be at our end, so.
First half hour, right?
I think she asked for it during the first half hour, yeah. But if we can make sure they get pinged, and I don't remember who's the presenter for the other one.
Dale, and he just joined.
Dale. Okay, excellent, excellent. Okay.
And it looks like Rosario just joined as well.
Okay, great.
Yes.
Okay, that's Ro. Okay, excellent. All right, so yeah, so this is the reordering of the agenda here from what Ashley posted. So the tech talk is first, and I just moved the common terminology into that slot where the tech talk was and moved this one up. So that's the new revised order. Does that work for everybody? Okay.
I apologize, I'll have to leave in the last half hour or so, but I don't think I'm an urgently needed person for most of this anyway. So.
And did your common terminology mail, did that get sent to the TAC?
It did, and I hope everyone's got it.
Okay, yep. Excellent.
Mm-mm.
That was the follow-up from the action from Nathaniel's action item last time.
That's correct, yeah. We've got some crosstalk from someone, I'm not sure who.
Looks like it's Pradeep. All right, so I think I'm going to go ahead and get started, and if Ashley, you can help make sure if there's any other crosstalk, just mute as people are joining. But all right, welcome all to the first meeting of 2022 for the TAC. As a reminder, this meeting is an open public meeting. The CCC tries to support open source projects to accelerate confidential computing. Every member is welcome. We try to be open and transparent and make this meeting be a good experience for everybody, whether they are a member or not. This meeting is open to the public, and so we value all inputs and we try to be collaborative. The only thing is that we really vote on is minutes approval and budget allocation. Other than that, it's generally a consensus-based meeting where we value all inputs, whether you're a member or not. So this meeting is covered by the Linux Foundation's antitrust policy. In case you're new, linuxfoundation.org/antitrust-policy. With that, if you just joined, we reordered the agenda based on requests from what Ashley first sent out. And so the tech talk is during the at the beginning here. And then we'll go through the rest of the agenda here. Later on, we have the annual project review from Keystone. And then common terminology is at the end to fill whatever available time is left. So right now, my expectation is about a half an hour for the tech talk, about a half an hour for the project review, maybe a half an hour for common terminology, and a half an hour for everything else put together. That's the rough estimate. We'll see how that goes. Let's quick check quorum here. So do we have Accenture? Is Giuseppe here? I do not see Giuseppe. Zongmin, are you here? Yep. Okay, Thomas Fasati, yes. Eric
Yep.
Northup. Or Shankaran as a designated backup? Nope. Okay, Yulia? No. Howard? Oops. I'm trying to scroll the wrong window here. Is Howard here? I don't see Howard. Dan is here. I'm here. And Lily? So currently I count 4. Where we need 1 more to achieve quorum. Did I count right? Anybody else spot one that I missed? Again, I counted Zongmin, Thomas, Dan, and myself. Okay, well, it won't matter until we get to the vote of the minutes, which is until after the tech talk. So we'll keep an eye out after that. But let's have anybody who is a new attendee and hasn't introduced themselves at 2 tech meetings. Let's go ahead and introduce yourself now. So let me start at the top of my list here, and let's see. Rayan, have you introduced yourself twice? I'll just call out a couple names here. Not hearing anything from Rayan. Dale, I know you have because you presented to at least 2 meetings, and you'll be on the agenda later, so you can reintroduce yourself then if you want. Jeff, I know that you've introduced yourself twice. Pradeep from IBM.
Yeah, I got introduced only once.
Okay.
So my name is Pradeep Parameshwaran. So I'm based out of the IBM Research Lab in Germany, and I'm a security architect by profession for IBM Z and Linux One.
Excellent. Thank you. Is it Saji? Saji.atai.
Yes, hello. Well, I'm from App Security and product manager here.
Great.
Dave, you hear me?
Yes, thank you.
Great.
And I see you have your camera on. Welcome.
Yes.
Is there anybody, and do you have 2 of you there?
Yes, this is Abner. It's from App Security too, and Ron, the VP R&D of our company, will come and join us.
That's who ran it. Okay, got it. Okay, welcome. Glad you can make it.
Thank you very much.
All right, I think that's everybody, unless I missed anybody. I think everybody else has introduced themselves in at least 2 meetings. All right, and with that, I'd like to welcome Rosario, and we're going to go ahead and start the TAC Tech Talk. And so this is to educate the TAC and to look for any opportunities for collaboration. So we'll get into that. So I'm going to stop sharing and let you start sharing.
Thanks, Dave. Meantime, I'm starting sharing. You may need to give me some rights. You cannot share screen. Okay, no, I should be able to share. So can you hear me?
Yes.
So that's the first thing that I'd like to make sure that happens. And then let's go with this. Clearly, I need to swap the screen. Very good. So first of all, Dave, thanks for having me here and let me present. So we'll talk about processing encrypted data and with the focus on fully homomorphic encryption, but many of the things that we talk about either are or are going to be common to what we talk today. And so it's a bit of a survey of the technology landscape, the standardization path, and the path forward. I go by Ro. I'm a principal engineer at Intel Labs. And at Intel Labs, very briefly, I own a mandate basically to enable privacy-enhanced computing and make it available basically to the business unit. And the goal really is to enable processing encrypted data in computing at a global scale by 2027, which is pretty reasonable given what I'm going to talk about. And among other things, I drive the DARPA Deprived program at Intel, which is building FHE hardware to make it practical or bring it into the domain of practicability. And I think this talk is of interest of this group because the focus from what I've read from the white paper is about the hardware enabled. Well, there will be hardware for fully homomorphic encryption pretty soon. I'm also the editor, and I started it actually 2 years ago, of the ISO IC 18033, which is fully homomorphic encryption. It extends basically the series of cryptography mechanisms at ISO IC, and I also lead the widely research on both the fundamental problems that concerns processing encrypted data and their application with the forum of leading academics worldwide. Before I was a researcher at Qualcomm, right, and I've always been in security research. And generally speaking, if you look at it, I've always been in research. One thing that I want to point out is that I think standardization is part of research, and in fact, as a part of standards boards, both technical and marketing in the past, in more application domain standards in IEEE and various alliances, and those are standards for secure communication and cryptography. Basically, I've been launching a few standards. So for me, standardization is a core part of research and to enable mechanisms. When we look at the processing encrypted data, we need to look at processing encrypted data as a powerful building block, right, in the pool of encryption tools that we have available to create security mechanisms. And the reason that is because when you process encrypted data without decryption, the bar of confidentiality in existing security solution in combination with existing security mechanism basically elevates, and there is a concrete opportunity to drive cross regulations and basically really decentralize computation while reducing the risk of third-party data leakage. Now, when we talk about, and we will quantify all of this in the coming slides, it's just kind of a summary. When we talk about the processing encrypted data until now, there's been limited adoption, if not for niche applications. Part of it is because of the performance tax that is associated with this type of cryptography that help you basically process the content of ciphertext without opening the envelope. And there is a lack of standardization and best practices really for instantiation, deployment, and maintenance on any solution that is built on these, let me call them a protocol more than security primitives, because there are security primitives, but ultimately, if we look at two or multi-party computation or homomorphic encryption are really protocol based on some, more than some hard problems, on some primitive based on hard problems. So they are protocol really. And then the other part of it is that they, as soon as you move from niche applications, the cost of development and integration of this solution within existing solutions is actually pretty high. So there is a high, there are high non-recurring engineering costs. Until now, many of the solutions, basically the landscape has been software only, that started with really proof of concept, but it evolved quickly. And the evolution is kind of useful because it shows us a couple of things that I will point out in a second. So if we kind of boil down into the core topic of this talk, like fully homomorphic encryption, we see libraries from small companies to incumbents and other things that are participated from universities. I mean, all of this started from universities anyway. We see, and these libraries predominantly, focus on a very subset of schemes compared to, homomorphic encryption is a large umbrella of things. There are compilers, again, produced by various contributors. This time I only mention industry, but there are a few that come from academia, and they are fueling basically the compilers that we are seeing here. They aim to reduce the non-recurring engineering costs, but they are schema specific. The libraries also don't talk to each other so far. And then the application domain is much unexplored until now, but we see that there are a few applications emerging in the past few years that have been very useful and that show exactly the key value of processing encrypted data, in particular homomorphic encryption, in helping humanity, really, and society at large. Like, for example, the example of the credit score in Korea, where millions of pension data were correlated with credit score data to boost up the credit score of people that are eligible to pension. And sure enough, a number of people were discovered that were eligible to more than they had. The COVID tracing is an example where collective intelligence across countries can be put together to face a global threat to humanity. Okay, so that's very important. And then there is the password stolen feature in Microsoft Edge, which in my opinion is a flagship example among others, because Microsoft has been one of the companies that really had enabled, whatever enabled means in this moment, but definitively the software that they have been producing until now has been the state of the art of homomorphic encryption, widely used, and that really enabled the field, and that the people use it more than anyone else. And here is the first case really in history in the past 10 years, where you see a company that produces a technology that produces homomorphic encryption, that uses it and deploy in its own product. So that's actually quite a key example here. And then there are many misunderstandings around homomorphic encryption that will clear up here. So there is this latest example of federated analytics with precision medicine coming from ETH. It's also associated to the startup that recently started from ETH, but it's a case of federated learning in the cloud. Now, schemes, when we talk about the scheme, we should not confuse them with their implementation within the library. Because of the overhead and the performance tax, many of the schemes are not really fully implemented in libraries, and this gives the perception that homomorphic encryption is kind of limited as a technology. But we will demystify this in a second. So the majority of the implementation of homomorphic encryption do not support fully, so that's the first thing. And it's a key problem for deployment. And on the other end, predominantly they have two-party, they deploy two-party protocols. So homomorphic encryption is pretty capable of doing multi-party. Of course, the performance tax limits its applicability in software on existing hardware platforms. So what's happening, and this is the new thing, is that in 3 to 5 years, you will have two good things. So the first thing is hardware accelerated homomorphic encryption and international standards. They are really just around the corner if we think that it's 3 to 5 years. So what does all means for Intel, and I think for industry in general, right? So when it comes to data encryption, Intel has been doing data encryption democratization by basically expanding the instruction set and using with the encryption capabilities, and using these encryption capabilities in combination with other security mechanisms to encrypt object, application secret, and even full virtual machine. And all that we are doing here is that anytime you don't use the data, you can encrypt, temporarily not use the data, you can encrypt it and place it somewhere, or you can encrypt it and send it over a secure channel, and everything is good. But what is missing really is that, anytime that you actually process the data, you do need to decrypt it, because the cryptography that we're using until now doesn't allow you to process encrypted data. But you can see that as cryptography percolated from theory to algorithms to software to optimized software to hardware, the next type of cryptography that is going to follow that trend is actually the cryptography that enables to process encrypted data. So let me give you an example of why among the techniques to process encrypted data, homomorphic encryption is actually a even more powerful building block for you. So if we are looking basically to a hospital that is trying to process medical images at a service deployed on the cloud, so the first thing is that the service comes from a third party, not from the cloud provider itself, will need to have an isolation environment basically to protect everything that concerns the service. And this is true whether the software is actually a vanilla software, like capable of processing clear text as we know it right now, or if it is software that is written in an homomorphic encryption library, which means that it's a software that is instrumented to process a certain type of encrypted data. Okay, but what happens with homomorphic encryption is that as the data basically enters the trusted execution environment, it can be processed, but it doesn't have to be decrypted. And that has a number of advantages, which I summarize in the following. So the first obvious one, right, is that the hospital can outsource the patient data securely. And the part that is securely here is, please do not get misled by the channel from the image to the part that is secure here is that at the choke point of the trusted execution environment, right, when the data stays encrypted, and the service can process the data without decrypting it. So what happens is that the hospital gets the service, but it's not letting the actual software that is processing the data to see the data. Okay, this is not about protecting that data from the infrastructure. It's about protecting that data from the software, right? So the part that is very unique about homomorphic encryption is that the data valuation remains the same in this case, but it can be increased in the case of, for example, federated learning on the cloud. So what does that mean? If I look at the data flow, right, whether we are doing homomorphic encryption or not, this data flow does not change, which means that the inference, basically, or the expected monetary value of the inference remains the same as long as homomorphic encryption does increase the costs of using the cloud infrastructure. And that's actually very powerful, and it's not common to other methods for processing encrypted data. Now, as we know, any security technology, and that's true for homomorphic encryption as well, or any cryptography, even though the bounds are a little bit tighter, or at least they are probably tighter, but in practice, it has to be seen. Any security technology at some point in time will fail. Okay, so the point here is that if trusted execution and other security mechanisms are circumvented, or if they are not circumvented but through legit choke point, the software within the trusted execution is compromised. Okay, the data that comes from the hospital is still encrypted and cannot be seen or abused. Actually, it can be abused, but the result of the abuse cannot be decrypted. And so from this perspective, what happens is that the service provider, and follow me during this discussion, because anytime that I'm trying to give a property, I'm actually pinpointing to the owner of something and what it is gaining. Okay, So anytime that we talk about the data, there are three questions that are always important to answer. Who owns the data? Where is the data? Who can access the data? So if we think like this, then homomorphic encryption is a powerful building block to elevate the bar of confidentiality. And the third party actually reduces its risk of third-party data leakage, which is very important. The other part of it is that usually, because currently data is decrypted within a protected environment, right? The data needs to be decrypted actually within some country boundaries at least, or some jurisdiction boundaries, because you are actually decrypting it. So with homomorphic encryption, you actually can completely, and that's the decentralization part that I was talking earlier, these servers can reside anywhere on the planet, because actually you're not decrypting in the cloud, you're not decrypting the data in the cloud. There is also another perk in all of this, which is because you don't need to decrypt to do the processing, right? You don't need to store anywhere at the site of at the processing site the secret key for decryption. So you are kind of eliminating one of the attack vectors, so to speak. So it's kind of interesting. This is a very simple example, but there are a lot of things that can be said out of this. So now let me back up some of the other things that I was telling you earlier. So what does really homomorphic encryption buys to you? Well, first of all, let's look into it. There is encryption, right? So encryption, it provides data confidentiality with some mathematical methods relying on a very hard problem. So as long as you encrypt and decrypt, everything works. The only thing that I want to point out, which is different from the traditional encryption, is that the encryption procedure is a linear map of the majority of the homomorphic encryption protocols that are implemented right now follow a public key, private key setting. So it's a linear map basically of the message at the public key to which it's add some noise. And it can be proven that this is like a sound crypto system. The point is that the encryption is non-deterministic, which means that anytime that I'm encrypting the same message, I'm going to get a different output. And that, affects the fact that if you are processing 2 times the same encrypted input, you will get different encrypted output that decrypts to the same value. So and that adds a number of issues from the point of view of security properties. But essentially, so this is adding confidentiality with encryption. It's doing so while you are processing things. As you identify basically the encryption procedure as a linear map, it's actually easy to see that you can do addition and multiplications on the ciphertext. And those, if you have a ring structure, which you actually do here, are complete to really process any type of computation. What we know is that with homomorphic, what is mostly known, and that's because now the libraries are implemented, is that homomorphic encryption basically can do addition, multiplication, so you can process a polynomial function. But actually, if the ciphertext encrypt bits, you can actually decrypt to an AND gate, which means that you can actually do arbitrary function, and I will quantify in a second of bounded complexity, provided this type of cryptography. The point of bounded complexity is that, because you are doing a non-deterministic encryption, you need to manage basically the fact that any time that you do operations, the noise grows. And these management operations are expensive, and there is where there is the actual complexity of homomorphic encryption. And so the reality is that you can correctly decrypt to the right result, requiring the output ciphertext within a certain noise budget, and I would add within some decoding boundaries, which is the real difficulty of translating a program, clear text program, in homomorphic encryption. That's why so much emphasis on the compilation. And then there is but if I look at encryption and homomorphic, we are adding confidentiality only while processing without decryption. And then there is the fully part that allows basically to compute arbitrary function of arbitrary complexity, which means that you can process perpetually, because you can introduce procedures to partly refresh the noise that accumulates after a number of operations.
Can I ask a quick question? Please?
Yeah.
Sorry. Which is, you talk about confidentiality. Presumably there's also integrity protection. Is that the case or not?
No, it is not the case, and that's exactly because I was about actually to touch upon this in the next slide. Thanks. So it's only confidentiality. To do integrity, there are cryptographic protocols that can be added to this, but it's not a message integrity token as we do in traditional cryptography, so to speak. If that answers your question. So this is only confidentiality. The reason is
it
really
does. Thank you.
Sounds like we'll come back to it, and I have some comments. If you don't get to it, then we can summarize those at the end about the relationship with TEs and stuff.
Mm-hmm. So the reason for this is really the fact that that for this type of cryptography, unlike existing cryptography, you are moving from a deterministic type of encryption to a non-deterministic type of encryption. And to back up the various claims about the performance tax, homomorphic encryption went a long way for the past 20 years. Before there was a type of homomorphic encryption that was allowing you to only process a chain of the same operation, either addition or multiplications. And because it was relying on modular multiplication, adding integrity is actually very easy. You can add a message authentication code. Moving forward, you actually gain the capacity of processing arbitrary function. That's what happened in the past 10 years. Okay, arbitrary functions, but that comes with the cost. The first is that you need to introduce this non-deterministic encryption that complicates the integration and deployment, not that it cannot be done. And the second is that the overhead of processing actually increased. And the most basically efficient way of doing homomorphic encryption nowadays is homomorphic encryption on polynomial rings. To give you an example, in 2010, in 2009, let's say 10, homomorphic encryption was overhead was 1 trillion times slower than clear text computation. Then, because you started adding the support for evaluating arithmetic circuits rather than Boolean functions, because you start evaluating multiple data at the same time, and then you started exposing more parallelism that existing architecture can take advantage of to some extent, then the overhead went down only to 1 million times. Okay, and this is basically in 2013. And since then, various way basically of mapping homomorphic encryption on existing artifact has been pursued widely, and it's still being pursued. But this is what I would call a really evolutionary approach to homomorphic encryption, because performance really didn't move much. And to quantify this a little bit more, we understand that in 2010, the performance was 1 million times lower, because the focus is on arithmetic on polynomial ring. The majority of the community focused basically on optimizing the arithmetic on polynomial rings only. And that gave the impression that you gained 2 orders of magnitude performance. But in practice, if you actually instrument a workload honestly, like without decryption, so what happens is that a toy neural network would run very, very slow on the state-of-the-art, with the toy data set on the state-of-the-art, basically processing infrastructure on GPU. Things don't change much with respect to CPU or FPGA, and I will not argument about that here. But basically, the point is that we are discovering the community is discovering, this is kind of a known fact, in many ways, many corners have been trying to cut, but now that the industry is actually fully looking into this, then we really want to do things, right? And then you start basically discovering that the evolutionary track of homomorphic encryption in the past 10 years is actually leading to a dead end, because assuming that the performance would scale, which does not, you would need basically hundreds of thousand cores to bring inference to a point that it's actually usable and consumable as it is in the clear text. Training is out of reach completely. And so it's a dead end. So what do we do with that? Well, in the past 10 years, that's the status. What happens is that there is a promise that in the coming 3 years, we will have a hardware that bridges the gaps, not only on the arithmetic, but on entire workload, which includes those management operations that I mentioned earlier. And DARPA was the first one actually that identified this need and invested in it. So Intel and Microsoft, I told you the time the PI of this program, so we are actually building this hardware and we are seeing this performance gap, and the main country, we are seeing basically filling this performance gap. And the main contributor is exactly not only that you are further specialized the arithmetic and the compute, but we are really redesigning the memory hierarchy. And which is a thing that in the past 10 years no one really has been looking at. And so we are collaborating with Microsoft on this. You know, the software stack, the library, and part of the computation things will target basically this new hardware that we are building. But this is, so to speak, that whatever didn't happen in 10 years is ought to happen in 3 years from now. Okay, and there will be a hardware acceleration for homomorphic encryption. This has consequences that I will highlight in a second. So I have 3 minutes, but 2 more slides, which is a good thing. Okay. So the other part of it that is important, as I've told you, as I do research on hardware, you know, meantime we were waiting, does DARPA award us or not? I didn't really roll my fingers around and wait, but I actually started the standardization path at ISO IC to extend basically the cryptography series with the fully homomorphic encryption. It's interesting because at ISO in this moment, there is a standards basically in the second committee draft, I think at this point, that looks at multi-party computation. There's these standards that look at homomorphic encryption. There are other working groups that one started very recently, and it's very interesting, that is about building lightweight cryptographic blocks for their use in combination with the processing encrypted data, specifically homomorphic encryption. So that's very important because those are basically these transition building blocks that if you look at a secure channel that is terminated somewhere, and you have your, today you have your advanced encryption standard, the GCM mode, that decrypts basically all these things into a secure endpoint, basically, into a secure perimeter at the endpoint. Now that AES GCM, if you actually replace that with a cipher that can be homomorphically evaluated, you have a situation in which the secure channel has in its input secure communication encrypted with AES, and if you homomorphically evaluate the decryption function, the output is basically still encrypted, but in a form that is homomorphic, which means that you can process it. And you have never decrypted the thing in the middle. Okay, so this is one of the examples that I would say, you know, for these type of things, you know, you do need the, first of all, global standards, and then the percolation of global standards basically into alliances, consortiums, and more application domain standards, which is part of the execution of basically my mandate, along with developing the technology. So at Intel, we are looking at the problem this way. So, and I think we, you know, as you can see, this focus in the middle is kind of reminding me continuously, maybe we have a shot here. So there is industry research on cryptography and security mechanisms in combination with existing security mechanisms. There is international standards. There are other initiatives that at least this is particularly interesting because it's looking really at the a security solution that is compound of various security mechanisms, including processing encrypted data. Not sure, they are not far along because it's a pretty recent kind of initiative, but it's actually what we need in addition to the foundational standards. And then academic research. The field is still evolving. The major milestone was really to lock down homomorphic encryption on polynomial rings. But the point is that the encryption procedure is quite expensive. So basically, the clear text expands quite a lot. In spite, you can kind of batch it and doing other things. And there is a lot of research still on homomorphic encryption on polynomial ring, but on more efficient formulations that try to reduce the data size expansion. And by doing that, actually, the overhead of computation basically in processing encrypted data also reduces. So you will see that as with the hardware, we were aiming basically to an overhead that is within 10x from clear text. And this is a wide range that depends on the function, the parameterization of cryptography. So this is cryptography, you need to parameterize it. And other things, there will be, you know, functions that run today that will run in real time, completely in real time. And more complex things that will suffer an overhead depending on the complexity. But the point is that what we are having as an input with the research is that we will have more efficient scheme that will run on the same hardware. And this is my last slide, which I think it's important to highlight. When we look at the NIST cybersecurity framework next to the more recent NIST privacy risk management framework, we see basic, and we also took the picture from one of your white paper, which actually is pretty pointy. We see basically that the only thing is that they are not oriented in the same way. We see basically that the bottom part of the picture from the confidential computing white paper is the part that really addresses the cybersecurity risks and democratize the technology to addressing these cybersecurities. The top part is more geared toward addressing the privacy risks because of keeping the data continuously encrypted. That's what the regulators are actually aiming for. They hint pretty strongly about that. But there is a portion in the middle, and this is where I want to really point your attention, that is common between the two parts. Like a privacy breach is something where the security mechanisms are circumvented somehow, right? And intended or unintended, whether it is a malicious attack or it's something that is just, I don't know, someone gets access to clear text to personal identifiable information. Okay, so that part is a gray area between the two, and definitively, you know, you have where all this privacy-preserving computation basically elevates the bar of confidentiality. And, you know, the privacy breaches are in the middle, but there is that as hardware-assisted CAM, all the privacy-preserving computation basically enter into the realm basically of privacy-enhancing computing. That's why I have in my mandate computing and not computation, because, you know, it becomes one tool into your utility belt to strengthen the basically the current system security solutions, as well as it gives you that other property of liberating data and other things that you hear from everyone. But as hardware is coming, I see it as moving also in the bottom part of this diagram. And so with this, I'll be happy to take questions, and thank you for your patience.
So I wanted to add on a couple of things back to Mike's question. So the homomorphicencryption.org had, I don't know if they still do during COVID times, but they're having periodic conferences. And so they invited me to one of them in the beginning of 2020, I think it was, on behalf of the CCC to represent the CCC to homomorphic encryption. So this invitation was basically reverse, where we were inviting a homomorphic encryption person to come to the CCC so that we had communication in both directions. And so one of the things that was talked about there, the threat model that the homomorphic encryption algorithms use, the term that was used was honest but curious. And so the honest but curious threat model, if you look at their, you know, like we have our threat model in the CCC white paper, right? The threat model in homomorphic encryption algorithm design was honest but curious, meaning they assume integrity and they provide protection against confidentiality. Okay, so that by itself then gives two opportunities that I saw for potential collaboration or using homomorphic encryption and TEs together. Okay, so one of those cases kind of matched what Ro put in the diagram that had the TE shield on it where the yeah, you know what I'm talking about. One of them was kind of alluded to in that one, and this is a case where you might be doing fully homomorphic encryption inside of a TE, right? And so why might you do that, right? Don't you get double protected things? So out of this, I said there's two opportunities for collaboration that I saw. One of them is this one, where you're doing FHE inside of a TE. So the things that you might be doing that for, number one, you're going to get attestation out of it. And so then you get the integrity protection by doing it in a TEE, right? Now you could say, well, maybe I could do integrity protection with attestation outside of a TEE and as a TE overkill, but certainly you're going to get attestation parts out of it, right? And so then your honest but curious threat model for one stuff is actually stronger because you're using the full TEE threat model. The other things that this one can potentially give you that I saw was this one actually provides you confidentiality, or it can provide you confidentiality of what operations are being done, right? Not just confidentiality of the data, but you could have confidentiality of the code, right? Some TE things could have code confidentiality. That's one of our optional things, right? So if you want to say, I wanted to protect and the queries being done against that data, or whether it's doing addition, multiplication, or fill in the blank for a more complicated operation, then doing a TE could protect what operations are being done on the data, not just protecting the data. And then the last one that might be an advantage there is, there's this fear that some of the TE algorithms might have bugs in the hardware or whatever that keep coming up over and over. And so maybe for some regulation things, there might be, an extra that says, I'm willing to spend, 1,000 times the perf or whatever it is in order to get that extra level of protection against, even if there was a bug in the TEE. So those are some reasons that, if somebody has a FHE library that can run inside of a TE, then I could see reasons why there could be such a project that would exist and be tested. And then Michael, go to you next, but I want to then comment on what the other case was that I saw for potential collaboration. And I can talk about in this picture here too. On the left side, you see the FHE encrypt and decrypt operations being done in the hospital. So the other case is if the TE is on the left side, right, it says, okay, all the encryption and decryption operations are done inside of a TEE on one side, and FHE is being done on the other side. So in this case, FHE isn't inside of a TE, they're being done on opposite sides of the same communication. And so if you think about use cases for, say, TEs on the edge, then one of the cases for TEs on the edge might be where you actually create the data, do the encryption and decryption operations inside the TEE, and then it's only ever processed encrypted outside of that. And so that's the other case where there might be opportunities for collaboration when they're just on two ends of the same protocol. So with that, since you originally asked the question, go ahead, Mike.
Yeah, so I agree with all of those. I think there's another one, which is possibly just a side use case of some of those, which is was kind of alluded to by Ro as well, I think, which is that most of the use cases for TEs and multi-party computation assume that the users of, or the owners of the data are fully able to evaluate the application doing the workload, doing the actual computation. And I think that may not always be the case. And this is that's a use case where as long as you trust the FHE algorithm, you actually have some extra layers of use cases. Does that make sense?
Yes, yes. If I may comment on this, thanks, Mike. Actually, that's a very pointy questions. So the case that Mike was so the traditional case for homomorphic encryption is called the delegation of computation, right? And that's true also for multi-party computation. So what does that mean is that whoever encrypts the data or participate with some portion of the data that is not the whole set of data also contributes with the function. So meaning that instruments the function to process this encrypted data. Now that belief basically has led to things like leveled homomorphic encryption and all the simplifications that we see in the libraries compared to the original protocol. But actually, if you look at this case, the case is actually different, because in this case, whoever process doesn't know the data, and whoever has the data doesn't know the function, right? And so this is why we have that F over there, like fully homomorphic encryption. So in order to enable this without basically having additional protocol between the user or additional kind of regulation and things, you need to decouple the instrumentation of the function from the encryption of the data, which when you do level homomorphic encryption, actually that's not the case. And so that's the fully part. Another comment that I wanted to make on Dave's things, like if there is an implementation error and things like that, then homomorphic encryption elevates the bar of confidentiality or any of those techniques. Well, cryptography needs to be, in any implementation, needs to be formally proven. And, you know, as a part, for example, of the DARPA deprived, and this cryptography is difficult to prove, because, you know, the data path widths when you come to hardware is actually very, very large. And, you know, as a part of one of the thrust of the DARPA deprived program is really the creation of mechanism for formal verification for the hardware and the various interfaces. So does that cover more? It definitely makes MISLIP better, so to speak, but it's kind of by design into the development of this project. And there's someone else, Thomas?
Oh, sorry. Go ahead, Thomas.
Oh, hi. Hi, Rosario. Thanks very much for the great presentation. So two questions. First is related to the cryptographic scheme, the underlying cryptographic scheme. Is the art problem susceptible to Shor? So is it quantum resistant? I would think so, but I wanted to check.
So that's a good, that's an excellent question. So in the ISO standard, I talked about the ISO standard, but I didn't tell you what we do there. And I apologize for this. Let me give you a couple of pointers, and then I will answer your question. So the first thing is that in the ISO standard, we capture specification for homomorphic encryption on polynomial rings for BGB, BFV, CKKS, and TFHE, right? Because those are the prominent methods based on ring LWE and etc. Now, we also look at security, because as Dave was talking about homomorphic encryption.org, I believe that one of the main contributions about homomorphic encryption.org was basically the table of security parameters, right? That table was actually very well acknowledged by experts in the working group 2 of the Joint Committee ISO-IC, right? But they weren't happy about having a single number, basically, or a single set of numbers. They wanted the first thing, security margin, which the standard is working on. The second thing is that the standard is giving both recommendation for parameters for classic security and post-quantum security. So the security strength vary a little bit. So the parameters are a little bit larger to do post-quantum security with, let's say, assurance. Okay, but it can be deployed for that level of security. You don't have to assume that when you deploy it, you automatically have post-quantum security.
Okay, and the post-quantum schemes, are they, or parameters, as you say, are they practical, or do you need to move to hardware in order to make them, you know, reasonably implementable?
I don't have this slide here, but I have basically a slide of trend that as cryptography evolves, right? The data types and the algorithms basically becomes bigger and bigger and bigger, which is basically really suggesting you that, you know, to keep on going with the application domain requirements, you really need to get to hardware acceleration. Homomorphic encryption, actually, you don't get nowhere. So once we have the hardware, I would be happy, because we can start exploring the application domain, which is largely unexplored today. So the point there is really, you know, what can you do? And it's not about the cryptography when it comes to processing encrypted data. It's what is driven by the application domain. The fact that you're processing encrypted data is like once you know how to deploy the cryptography well, it becomes a collateral, so to speak, and they are functional units if you look at them from the hardware perspective. Yeah, does that answer your question?
It does. Thank you very much. I have another, but I will let Eric. I don't want to monopolize the space.
Yeah, I know. Ro, you have a hard stop at the top of the hour, so we're going to maybe Eric might have the last question here.
All right. I have two. Hopefully, maybe there'll be more pointers to it. The first one is I haven't actually seen anything that says for the type of operation, add, subtract, delete, or whatever they are, if there is a delta in performance where you have to show the operation set possible, what the operations are and whether they're complete and whether there's delta in performance. That would be interesting. The other one that I want to get in before I lose it is actually on the previous slide that we were showing. And that is per object, when you're sending a message over to the cloud, the issue is, do you have a different encryption operation for each object? So you don't, let's say, have null or zero repeat so many times that people can guess the values by context. And so I was wondering if there is operations so that you actually track as part of your encryption and decryption the meaning per object going over to the cloud provider.
Excellent question. So I hinted let me answer the first one. I hinted to the performance here, and on the next slide, probably better. So here they are talking about really, so when you do addition and multiplication into a ring in general, that's complete. So you can do arbitrary function with that. So that's the first thing. And the second thing is that here really what we are pointing at is the cost of multiplication. So you can have basically polynomials that are thousands of elements, and each element basically is thousands of bits to the modular multiplications. I don't know if I have these slides in the backup, but practically what happens is that the clear text multiplication on a CPU takes a nanosecond. A multiplications of ciphertext for reasonable parameters, all right, within a function may take tens of milliseconds to 70 milliseconds. So that's the gap, and that's the million that is here. Okay,
all right, that's
so
helpful.
No, and I can I can provide more data. In the interest of the 30 minutes, I got a lot of slides from this talk. Now you can basically use a single instruction, multiple data, and pack multiple basically clear text within a single ciphertext. So into that 10 or 70 milliseconds, right? Tens of milliseconds, you can compute the amortized value of a multiplication. The point is that you can't always batch things, especially if you're doing real-time computation. And there is this legend in the homomorphic encryption communities that homomorphic encryption is practical for batch computation. But then my counter argument is that, well, machine learning training is a batch computation and it's out of reach. So there is, some limitation even to that. So to your second, and I hope that answer to your other question here, does it leak something because the data format that you have inside it tells you something about, how the function process. Okay, but it doesn't tell you anything about the data, even if you pack them, because if you start basically arranging the data within a ciphertext with certain layout, your function needs to be able to know that layout is there, otherwise it doesn't process correctly, right? So that part is let's say, part of metadata of a function that needs to be known. If you do bootstrapping, however, okay, much of it is completely decoupled from the arrangement of the data and the encryption parameters either. Okay, so, and that's the reason because I really insist on this fully homomorphic encryption. So enabling bootstrapping, liberates us for some of those things that might hint to, how do I say this, algorithmic side channel, do you want to call it? Yeah, that's probably the right way to do it. So it can be architected in a way, and that's exactly the effort of standardizing things and normalizing things with respect to the practice that is very fragmented. Does it answer your question?
Appreciate it. I'd love to see the slides and perhaps talk more in the future. This is good.
Yep. All right. Thanks, Ro.
Thanks.
I know we need to wrap up here so we can let you get your next meeting. So I'm going to go ahead and
Thank you
start
very
sharing again.
much.
But
Thank
this
you.
has been great, and
Thanks, Ro.
we have a project for doing like multi-party computation in TEs, which is what is that, Veracruz, if I remember right, but not one specifically for doing HE. So there would be opportunities if somebody did have a project that did that we'd be very interested, whether it was in the CCC or not. So
Thank you. Bye.
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 All right. I believe we have quorum now that Howard has joined us, and so I'm going to do a quick see if we can do in maybe between 5 and 10 minutes max all of these items here so that we can get to Keystone. So the approval of minutes. The November 18th minutes was the one that we didn't approve in the last call, and it was going to be over email. I don't remember if there was a vote over email. Actually, tell me if there was, but otherwise, I just wanted to have a vote for approval now on the November 18th minutes.
I don't believe there was.
Okay, then let's just do a call for right now. So it's been long enough, so I want to call for a vote out of the voting members. Is there anybody that would has amendments for the November 18th minutes or needs to be logged as abstain? Okay, hearing nothing, I will assume that the November 18th minutes have passed. And the other one, the December 2nd meetings, we did vote on, as Dan observed. So I'm not going to call for the vote on that one, although I think Dan did provide an amendment after approval, as I think I did it to Ashley as well. So, but we have to call for a vote here.
Those have been updated and uploaded
Okay, great.
to the video.
Okay, December 16th, when I checked at the beginning of the call, Dan's comments had not yet been addressed in the December 16th minutes. Has that been done yet? All I did is I looked at the very bottom to see if the date in the adjournment, which was the very last comment, because that was easy for me to check, and that hadn't been done. So are we ready to vote on this one, or do we want to defer this one until next time? I don't know of any other comments. I looked at them and I don't know of any feedback other than the ones that Dan already called out. And so unless I'm told otherwise, I'm going to propose, based on Dan's comments, that we defer this vote to the next meeting. Is that okay with you, Dan? Because I think your point about was a discussion that there should at least be a bullet about that's not in there right now. So it would be an addition. And so that's why I'm hesitant to call for a vote, even if it was just updated.
Yeah, I think that'd be best.
Okay. All right. So let's do action item review. And one of the things Dan called out was maybe this, I don't know if there's additional action items that aren't on this list. And so maybe people can help check, but the DEI training, and if there's anybody that wants to voluntarily do that, but otherwise I'll just defer this discussion until next meeting, because I'm sure it's not done. In the interest of time, let's just report on this next meeting, or people are free to put stuff in chat. Any other things people actually want to volunteer the status on? Nathaniel's, that one was done, right? That was the mail that Mike, you sent to the list, right?
Correct.
All right. And anything else on an action item that people actually want to volunteer a status on? I think this one was also done, the one from Dan, number 3. Okay. The Grameen have the webinar this month, and what's the date for that one?
That's January 20th, and the registration will be sent today.
Okay. Great. And then this is the one that's on our agenda today, the Keystone one. All right, updates from Outreach Committee. Outreach met yesterday. Is there anything of note that was questions or feedback for the TAC?
Nope, nothing to note other than the CCC newsletter will be distributed 2 weeks from now. And that'll be the first newsletter to go out on a quarterly basis.
Okay. Were there any other webinar topics that they're looking for, or are they all good for the next bit here? Because I only have the January 2022 one on here. Are they already good for a queue for a while?
We have another one. NARCS is going to present. We're just looking for a date there right now. And then Intel, Mark and Jesse for Hardware Trust in February. We have a new contact, so they're working behind the scenes to identify a date as well as speakers for that webinar. So more to come there.
Okay, so is NRX, is that February or is that TBD?
TBD.
Okay, sometime in 2022, NRX will have another webinar. Got it.
Sometime first quarter
Hopefully,
2022.
yeah, exactly.
Q1, okay. All right. Any other pieces of feedback on action items? Okay. Then with that, I think we are up to Dale's presentation. So Dale, if you want to give us your annual report, and you have about a half an hour.
Yeah, sure. Okay. I don't think I would need like half an hour, but let me share my.
Not
You
a
see
problem.
the slides?
Yeah.
Yeah. So I'm gonna briefly go over the progress we made in our projects, and then like some of the ongoing efforts as well, to give a little like overview of like what's going on in the project. So to begin with, the goals of the project is to enable TEAs on all RISC-V processors. We're achieving this by following RISC-V standard ISA so far, or sub-ISA. It makes it portable over like multiple RISC-V platforms very easily. And then the other goal is to make TE easy to customize depending on needs. We achieve this by separating the base implementation of the TE, which includes the memory isolation against the software adversary, plus the remote attestation based on hardware silicon root of trust, versus platform-specific implementation, all done in the low-level software, which is the security monitor. And this kind of design allows us to reuse the implementation across multiple platforms. And then the final goal of the project is to reduce the cost of building TE by kind of having these common implementation for RISC-V, like common implementation of TE for RISC-V processors. You can actually, as a hardware manufacturer who wants to build a TE into their hardware, they can reduce the hardware integration or verification cost. And also they can reuse all the software tools and portable examples on top of the Keystone on their hardware. So that's the overview of the kind of what we're heading to. And here's the summary of 2021. There are a few major updates. One is we have begin to support new platforms, 3 new platforms, namely. So one is the microSemi spoolifier platform, and then the CVA6, which was from Open Hardware Group, and the Renode, which is a software simulator. And then we worked a little bit on improving the code quality of the project. I'll talk about it in a next few slides. We have a new sub-projects. Mainly they're both research and development projects, and I'll go over them as well. We've been recently started collaboration with Rios Lab, which is a lab that aims to have a fully open source hardware. And then we have improved the documentation and examples. And we're seeing a lot of like academic users in our like community. So I'll talk about that a little bit more. So 3 new platforms are available. So what it means is that you can run Keystone and all the Keystone software stack on top of these platforms. So first one is Renode. It's a software framework for hardware simulation made by Ant Micro company. And what you can do with Renode is that you can configure any arbitrary SoC with by just writing a configuration file. So you can add a core and a specific core like spec, and also you can add some of the IP blocks into the configuration. Then you can kind of simulate the hardware. We confirmed that Keystone runs in some like simulated hardware that we configured using Renode. obviously it was a RISC-V hardware, and it shows that because Keystone sticks to the standard ISA, RISC-V standard ISA can be, it is very portable around the multiple RISC-V processors. The other platform is MPFS by Microchip. It's a PolarFire FPGA board with a RISC-V processor. Keystone also runs in that platform, and there has been an external contribution from Open Hardware Group that was able to port Keystone to a 6-stage in-order processor called CVA6. So the next update is code quality. So we've been putting a lot of efforts on refactoring and making more like accessible from the outside of the team. So main refactoring was done in SDK. So we have cleared up a lot of like code in the SDK, especially because that's the most user-facing code base. And then we have improved deformatting and also like configurability so that you can switch between 32-bit and 64-bit modes. And then finally, we have improved the CI/CD pipeline using Circle CI. We have built the Docker image, pre-built Docker image, so that we can kind of reduce the amount of time it takes to fully build and test the entire project and all the sub-project, sub-modules. And we have added unit tests to the main part of the code base. There has been a lot of like new sub-projects. Those are all ongoing, so I wouldn't go too deep into this, but there's been one project on trusted loader and dynamic library. Keystone still doesn't support the dynamic library for some reason, and we're trying to figure out like what is the best way to do it in the RISC-V. So we were thinking about pretty similar way, like what people did in the Intel with the Intel SGX, like library OS, but this will be achieved by trusted loader instead of like wrapping all the libraries in the library OS, because we have a supervisor privilege in Keystone, and the trusted loader will be able to load and manage all the address mapping of the standard libraries when you load it. So that's one project, and the another project that's ongoing. Oh yeah, that's done by Kathy Lu and Watehira from the team. And then the other projects include improving measure boot and attestation. So we are looking into what other projects are doing with this measure boot and attestation. One of the example is the Google's OpenTitan and the Microsoft's DICE. We are trying to see if there's any kind of standard coming along with these kind of implementations, and then trying to come up with some more like industry-friendly measure boot and attestation. This is led by Rohit from our team. And then the third project is scalable memory isolation RISC-V H extension. So one of the key limitation of Keystone is the number of concurrent enclaves you can run. This was a huge problem, and we're looking into the RISC-V hypervisor extension. So RISC-V is now kind of, they're kind of freezing the H extension. So now we have version 1.0.0 RC for the hypervisor extension. It allows you to use multiple layer of address translation and interrupt controlling in the hypervisor privilege mode. So we're trying to see if there's any chance for us to use this extension to make the memory isolation scalable, so that we can increase the number of concurrent enclaves in Keystone. So finally, there's an academic project by Kathy Lu She's working on preventing side channel attacks and dynamic libraries, and she's doing it on top of the first sub-project. Yeah, so that's a kind of overview of like new sub-projects. And then there has been a collaboration on hardware. So one of the big problem, I would say one big limitation of Keystone is that since it's more focused on like building the TEE itself instead of like having a software system, right? You also need to work with some hardware, and we do really need some hardware that really have everything for Keystone, including the silicon root of trust. And we recently started collaborating on this hardware. So there's a Pico Rio project from Rios Lab. And what they're doing is that they want to fully open source a hardware and then tape out the hardware so that anyone can kind of take that design, take the entire design and easy to kind of manufacture, tape out. And here fully means not just the core architecture. There has been a lot of like open source core written in Verilog or system Verilog, but what their goal is to open source all the peripherals and hopefully including the memory controller and all the IPs they're relying on. So this includes the AES accelerator or the device lifecycle management IP or something like that. And they're planning to tape this out by end of 2022. There's not much thing to do from Keystone's end, except that we may need to collaborate with them on integrating the remote attestation and the silicon root of trust of theirs and then the Keystones. So yeah, so that's a kind of ongoing collaboration. And then there's been a few updates on documentation examples. We have improved the attestation tutorial so that people can like easily follow the attestation protocol that we're providing. And then we were able to port two kind of popular applications, which are Redis and SQLite3. These are all, I believe they are ready to be merged, but like, yeah, they'll be soon to be merged. So to see some statistics, we're seeing growing number of academic users. So a lot of like we've been seeing a lot of like academic researchers using Keystone as kind of their baseline, or they're using Keystone to kind of prototype their ideas on it. And that's actually a good thing. Looking at the stars in the GitHub, we're seeing an increasing number of stars. So it means that people are still very interested in our project. And it's kind of growing in the middle of growing phase. Yeah, so that's all for the review. Is there any questions?
See, I post a link into the chat. Since you're sharing, if you can click on it and bring it up, this would have the questions the tech wants to make sure we always go through it during any annual review.
Okay.
Do you have that out of the chat? Otherwise, I can pull it up. But since you're already sharing, it's at the bottom.
Okay. Yeah, I can. I need to reshare because it was PowerPoint.
Okay, click on annual review process in the first paragraph there. It'll just jump down into the right section. It's like section 4 or something, so. Yeah, okay, there it is. Well, it was there. I think it's down at the bottom.
It's at the very end of the doc, yeah.
Yeah. All right, there we go. So let's walk through each of those 4 questions here. The first one is about whether any answers to the original submission template have changed. So for example, did you add any new dependencies that you didn't have a year ago? And by dependencies, on other projects and things is the first question. One example.
No, we haven't added any new dependencies.
Okay. To your knowledge, other than the things you've already mentioned, is there anything else in the submission template that's changed? Sounds like no, but usually we just ask for a specific confirmation, so nothing else has changed.
Yeah.
Okay. Number 2, your graphs were relevant to number 2. So just a summary, you still believe that Sandbox is the correct level for it, correct? And it's on track to be growing.
Yeah, it's on track to be growing, and it's still, I would say it's still in a sandbox stage.
Yeah, since you were talking mostly about academic use and not in use in production yet, but yeah, but I'd love to see the growth. Thanks for showing those pictures at the graphs. Unless there's any other questions there. Number 3 is about budget allocations, right? What things did you actually use in 2021? And there are things that you would want to use in 2022, whether it's, outreachy interns or whether it's hardware requests or whatever,
So for the budget, fortunately, we're kind of school projects. We're using like a lot of open source tools for free. For example, like CircleCI, they're offering like free tier plan, and also we're using GitHub like for university, so it's also free. So we haven't spent any budget like 2021, I believe. But I would be happy to see some interns who are, if they're interested in Keystone, I would be happy to mentor them in 2022.
Okay, that would be the outreachy program is the one that's the approved budget policy from the TAC right now, is that if you were applying for an outreachy intern, and Nick here on the call can talk more about that if you have any questions.
Yeah, Nick actually sent me an email this morning, so I'll talk to him.
Okay. And do you expect that you would want, since we just had policy approvals for budgets for getting either hardware or perhaps subscribing to some hardware if it happened to be done as a service or something like that, is there any hardware requests? Because we just had the first one from another project that got submitted that says we'd like to order, and it's like up to $7,500 of equipment or whatever for getting TE-based hardware that you need. Is there anything that you anticipate asking for during 2022? Because now that is an option for you.
Yeah, I would be happy to, if there's a budget, I would be happy to order some RISC-V, kind of existing RISC-V dev course for people, because we're kind of running out of the test board for the people who are newly joining. So that would be a good if that's an option, I would be very interested.
Yeah, the recent things that we voted on at the end of last year is we have 2 budget line items that we created. One is that each project that asks and gives us specific details as to what they would want can ask for up to $7,500 of hardware. In order to do that, you'd submit, here's exactly the piece of hardware that I wanted, and so on. And there's 2 different ways that could work. It could be that that the project orders it and submits to Brian for reimbursement. And the other way is you submit the request and Brian takes care of ordering it and having it be shipped or whatever. Brian, correct me if I got that wrong, but
you got it right.
So you'd send a piece of email to the TAC saying, here's exactly what I'm looking for, and here's which process that I want to follow, and then Brian can help you.
Okay.
The second policy, just FYI, is that there's up to $15,000 per year for shared infrastructure. So for example, if there was some cloud service that RISC-V and other projects would both want to use, then the TAC can budget something for, I don't know, whether it's GitHub runners or something like that that multiple projects should use, meaning not hardware that you have that's your project or whatever, but things that are shared. So think about if there's any ideas that you have for things that say, whether it's a GitHub self-host runner or whatever it is that might be shareable across projects, and there's even more budget that's available, but it has to be shareable.
Okay, gotcha.
So this is new. This is, if you haven't heard about it, it's because we just voted on that at the end of last year. So, so yeah, think about that, and now hopefully you know what the process is. All right. So number 4 is then, did you use any of the LF license scans? So some projects did, some projects didn't. Did you have any license scans to be done for your project?
No, we haven't.
Would you like that or not? That's another thing that's available on request.
Could you explain more about like what's license scanning?
Somebody else want to take that one? I can, but if there's somebody else, I think there's an expert. Go ahead.
It just makes sure that it helps you make sure that you're compliant with open source licensing. So if you've accidentally grabbed something that is an incompatible open source license with your project, it helps you be aware of that so you can correct it.
Yeah, I would be interested. Yeah, I think that is kind of necessary for our project. We haven't done that before. So all the licenses are like manually tracked. So yeah, that'd be good.
Okay, so if this is a request, then Brian or Ashley, do you know who takes care of that of LF? Where do we send the request to? Is that something you take care of, Brian, or who does that?
We can follow up on that one. There's been some change on the LF side and staffing for the folks who've been involved in doing this. So I do need to go take a look and figure out what the current process is. But I can take that as an action.
Gotcha. Yeah. So Dale, the way that the LF scans work is the LF does it for the CCC, and they just have a queue of things where we have a certain set of budgets. So you just kind of get in the queue, and the next time that they have a slot, the next person in the queue gets a license scan. And so we just add your project into the queue, and then the license scan will pop out in a couple months from now at the most. So
okay, sounds good.
I would also say there are some other, just really quick, there are a couple of other ways to do this if you don't want to wait that long. We can load the project into LFX, which is one of the Linux Foundation suites of tools, and it will do a basic license scan, effectively looking for declared licenses, and that's something that can be done on an ongoing basis. I don't know much more about the details than what I just gave you, but if that's something you'd be interested in, we could look into that as well.
So LFX?
LFX, yeah.
Okay.
It's a set of tools the Linux Foundation's in the process of building out. One of those things does include license scanning.
I see.
So two requests for Ashley. If you can get the LFX link into the minutes, number 1, and number 2, if you can have maybe an action item for Brian to figure out what the latest LF license scan mechanism is, and how do we get that started for this project? So
Will do.
Okay. That was number 4. The stuff below that talks about, so let me just ask, what is your current, do you have a current documented security reporting process? And so let's say somebody finds a vulnerability either in your project or perhaps in one of the dependencies that your project sits on top of, right? You're a TLS library or whatever it is you're using for crypto libraries, right? I don't remember without checking your dependencies. How would they report that to you today?
So I believe right now people have been using the GitHub issue. They've been using GitHub to.
So that would be fine if there's no embargo or something around it. If it's fine to reveal, but if it's a security vulnerability, then often a researcher will not want to put it into the public, or at least out of consideration for the project to not put it in the public until after there's a patch or something like that. Do you have any process for that kind of thing yet, or not right now?
We don't have that kind of process. Do you think that we need to have one?
At some point in your maturity life cycle, you'll probably need that. And I guess it's up to if you only have academic use and you don't care if any vulnerabilities are public information, then you might push that later down the road. But it is something that, before you get into production use, you'll probably want to have that process in place. So I guess that's up to your planning. So I don't know if anybody
Yeah,
else on TAC has an opinion on that.
Even if it's in a sandbox stage, I think I would want to see like what other projects are doing, like how other projects are handling this kind of issues.
Did you already drop off? I know Mike had to leave during the last half hour since I know NARCS is another sandbox project, has a fairly well-established security reporting process. Is there anybody else in the call that's representing another sandbox project, maybe a mentor or something that wanted us to talk about what theirs has done? I know Open Enclaves, but Open Enclaves is incubation stage. So I'm looking for another incubation stage project to explain. Any other sandbox stage projects that people want to talk about?
Oh, hi, Dave. I can get in touch with Mike later on and help this process as well.
I think if I remember right, NARCS had some process that even allowed anonymity if that was required of the reporter, and had a way of setting up a channel through Rocket or something like that. I may not be remembering right, but
yeah, Rocket Chats, exactly.
Rocket Chats, yeah, you had a way to have stuff be confidential coming in through Rocket Chat.
Yes, perfect.
Any other sandbox projects that have a private reporting mechanism, a non-public reporting mechanism? I'd say it might be that the majority of the sandbox projects right now don't have any, just like you guys don't, but there are some that do if you're looking for a comparable. All right, any other questions from the TAC that I did not cover? Dan, anything that I missed that you noticed?
No, and it was great. You could drop the link to the process in the chat. I feel like I'm always looking for that at the last minute. Maybe, so maybe in the next agenda that we have an annual review, it would be good if we can get that in there along with the link to the original proposal. I would kind of guess for most of us to actually see if there's a difference from the original proposal is like an off the cuff remark that happens during the meeting instead of a considered action.
That is a great point. You got that, Ashley?
Yes, thank you.
Thanks.
Okay. Any other questions for Dale? All right, if not, thank you. Keep up the good work in your project.
Thank you very much.
All right, so if you want to stop sharing, then we will move on to share screen. All right. So next up, we want to reserve at least 2 minutes at the end, but otherwise we can go to the common terminology discussion for the next almost half hour. So I think I'm going to propose that our goal, remind us that our goal is to be able to, I think, get to a white paper. So far, this originally started as the document here, the Google Doc, way back when it was first created, it was a proposal to the TAC that the TAC should do some work. It's then morphed into a collection of our internal discussions and notes about this in a way in text form. And eventually we want this to be cleaned up enough to actually become a white paper, which has a long ways to go to get there. But a lot of the technical content is there, but a lot of the massaging and there's extra cruft in here and so on that needs to be done. But let me first ask, is there anybody that did significant contributions since the last meeting? I know a lot of people couldn't make the last meeting. And I think the last new stuff that I remember is this deployability prerequisites, which maybe some people haven't seen that if they weren't there at that meeting, because that was the middle of December and attendance was low because lots of people were on vacation. And so unless there's somebody that wants to present something right now, I was going to start back at the top. And I was just going to kind of lead a discussion on some of the next steps that have to happen. And because there are a couple of comments in here that people have added, thank you, that are worth discussing, such as Eric's one right here, which does affect this table here. So that's one of the main ones I want to get to, Eric, just a heads up, but I'll get down to there in a minute. So.
Sure, just one quick one.
Yeah,
because
go ahead.
nobody liked the idea of application column, I have a different version of the picture, but because
Okay.
people talked about everything from package to whatnot, I do have a new version that kills the application view. So we can probably just skip the application discussion.
Okay. Do you have something, when we get to that in a minute here, do you have a diagram you want to share on the screen?
Yeah, I could do that when we get there. It's not a rush.
All right. No, I'm just giving you a heads up now so you can get it up on your screen so you can share when we get to that. So
I got it.
All right. The title here was originally the proposal for what CCC should do to establish common confidential terminology. My current working proposal for what the name of an eventual white paper might be would be Common Terminology for Confidential Computing. What do people think of that as a title for a public white paper? Common Terminology for Confidential Computing.
Works for me.
If it does, I'm just going to accept this unless people have wordsmithing or objections. So, okay, hearing no objections, I'm just going to accept those. Okay. All right, so we haven't had any major changes to introductions, so there may be some changes there later. Now we get into the point that there's been lots of discussion about, and things might not be in the right order in the document and so on. But my belief is that in previous meetings, we've settled on, I think we have consensus on a couple things. Number one, that there really are two different layers, what the hardware provides and then what's exposed up on top. And that's kind of illustrated in Eric's picture here. Well, this top part, VM-based versus process-based, is one layer, and confidential VM app, et cetera, down here is another layer. So the fact that there are two layers, I think we have consensus on. The fact that you can do one thing inside of another thing. I think we also had consensus that we should use different terms, that we shouldn't try to use the same term. We should have one set of terms for one layer and a different set of terms for the other layer. And so this old text that I wrote about having some terms independent of layer is actually wrong now. And so this is old text that should move to the graveyard, right? And I think somewhere I put in a note about this needs to move to the graveyard because this is no longer consensus, that we never want to reuse terminology between two different layers. And then I think we had some discussion about what those things were. So if we label the two layers, the closest thing that I could find to a consensus was maybe packaging model for the thing on the bottom, right? This part down here, I think, I don't know if there's a better term, but that's the one that I heard us using a bunch of times, was packaging model, as opposed to this top layer, which was like isolation model, which is what I think I heard. So terminology for isolation model and packaging model, are those two labels the right terms for the two layers, or is there a better label for each of the layers?
I like these terms.
I think they were originally your terms, so Eric, so.
I did like them, yes.
Isolation technology or isolation model? Yeah, here's what I was looking for. It's these two right here. Isolation technology or isolation model? Who else was talking? Dan, I think you had trying to say something.
Yeah, I think I was interpreting these opposite of what you just said, where like the isolation technology is what the TE is actually giving you, and then you try to package something over that. Yes,
what you said is what I meant.
Okay.
But my question here is, the thing that the hardware provides, would you call that the isolation technology or the isolation model of the hardware? What's the word that you would use?
I don't know if I have anything better for that right now, other than just defaulting back to the TE definition.
Steve, in your NGUnit glossary, did you have any particular term for this one? I can't remember.
We were using the hardware and calling that confidential compute, and the packaging model was, we didn't have a term specifically for that, but we were, a confidential cloud is what we had at the very top. And I know I've got an action item to define that down later, because I think that's a bigger concept than what we're describing here is the packaging model.
Okay. So Eric, I'm going to propose isolation model. You can see right here, isolation model is one place, down here is technology. So between these two, I'm going to propose that this one here change to my assistant suggesting.
Yeah, that's fine.
Should
I
be.
think one of the good things about
Okay.
isolation
Okay.
models, you can have different technologies underneath. So I do
Exactly,
like
right.
Yeah.
So like SGX is a technology, right? You know, process-based isolation or something is the model, right? And there's different technologies from different vendors. So that's
Yeah,
where I
works
go
for
for
me.
model. Okay. Okay, so isolation model and packaging model are the terms that we're going to use. Among the isolation model categories up here, we have VM-based and process-based, and this is where that one, Eric, your point somewhere I think does apply here. I forget where, this one here, or perhaps this. Okay, so this is one of the things that I wanted to bring up. If I look at this diagram here, and actually you said you have a newer diagram, so why don't you bring up your newer diagram and I'll ask it there, because I think whether there's 2 things at the top here, or there's 3 things at the top is part of the discussion we want to have. So I'm going to stop. You go ahead and share your new diagram.
I'll share. And
okay. And where I'm going with this question is to take 2 examples, right? The model used by SGX and the model used by, let's say, Opti over Trust Zone are different, I think, different hardware-based models, but maybe somebody from ARM can correct me if that's not the case. And all right, so in this one, what's not in any of these, look at the red boxes are what's inside the TEE, correct?
Yes.
Yeah. So what's not in there is you'll notice that there's the VM-based ones, which have a guest OS, which would be, you know, your guest OS might be Linux, for example, right? And the process-based ones, there's never any guest OS. It's always app data and library. When you look at, Trust Zone, then you actually have in your TCB, you have more than just that. You actually have a trusted OS. In other words, you have something that spans multiple processes that sits in the TEE. And that diagram is not anywhere on the slide right now. And so the main difference, so unless somebody tells me that, oh, no, that's part of the middleware and underneath the hardware is actually the same, that's not my understanding, but I could be wrong. So the way that you would draw the picture with Trust Zone would actually have another thing inside the red box besides the app data and the library. And that it would be the trusted OS, which is not Linux. It's more like, Opti is one example. I think Trusty is another example. And there might be a third one that's out there whose name is escaping me. There are things that can run on top of Trust Zone. Thomas, were you going to say something, or was that Eric?
Hafnium, the third example.
Okay, Hafnia, yeah. If there exists another type of isolation, and that's kind of my question, because things like, Open Enclave, and I forget which other things run on both, I think NRX may run on Trust Zone. I can't remember what else. There's some other project that also runs on Trust Zone. The difference, once you have a trusted OS, then there are processes, to use the term loosely, that run on top of that inside the TEE, although I believe in the Trust Zone case, it's always passive. There's no threading model in there. But there is a process in terms of the memory isolation, I think, between different applications in the app data and library parts. And so in Opti, those are called trusted apps or trusted applications, or TAs is the abbreviation. And so you might think of the Trust Zone, Opti, et cetera, type model as being process-based inside the TEE, whereas things like SGX are just library-based inside the TEE, right? The red boxes on the screen right now under process-based, you can see all are on a library by library basis and nothing below that, and that's correct for SGX. And so what I wonder is SGX more like library-based thing at the hardware level, whereas something like Trust Zone is more like process-based at the hardware level? And so that's what makes me wonder whether there's VM-based hardware, process-based hardware, and library-based hardware. And the diagrams on Eric's stuff were actually correct for the library-based one, but not for the process-based one. That's my
And
question.
I would totally agree with that. But some of the things I poked around a while ago, I'd love to get Thomas's thoughts here. There's no reason we can't add more exemplary comments, or columns. The goal of the slide really was to show that the packaging models repeat. And so I have no problem adding additional examples just to show that we have an issue with our packaging terminology that needs to be brought into consensus.
Yeah, I would like somebody from ARM to confirm my understanding that the hardware itself does have a knowledge of multiple processes and at the hardware level inside the TEE. That is my understanding. So, and provides isolation between them inside the TEE.
So you talk about hardware, but effectively is the secure partition manager that does that thing. It has the understanding is it's firmware. Yeah.
Okay, firmware, sure.
Yeah.
Okay. So then I would propose, Eric, that go ahead.
Does that put multiple processes in the same, or can it put multiple processes in the same context?
Yes. Yeah. I think it provides isolation between the processes, but it also has a model for sharing stuff between the processes.
Yeah.
In Trust Zone, there are separate processes. They don't have any threads, right? The threads are always in the context of a single call-in from the REE, right? So a thread is scheduled only when there's a thread available from the REE, and then it returns and does stuff. But as far as everything other than the threading model, it's a full process.
I'll throw another thing in there is that the first time I showed these diagrams to Thomas, I did have process in the red dotted. So he said, yeah, that looks good. And then we changed it later. So I think an action would be for Thomas and I to go back and try to see if we have additional columns to add to make sure Trust Zone is covered, like he probably thought he did in the earlier ones.
Because then, all right, so the proposal then is we have 3 isolation models, which is VM-based, process-based, and library-based. And SGX is an example of a library-based. TDX is an example of a VM-based, and Trust Zone is an example of a process-based.
I like that.
Other examples. So.
I'd be happy to help work that through and provide a proposal back if Thomas says yes.
So Dale, can you say, if you understand, do those terms make sense to you? And if so, which ones does RISC-V native hardware support? I just want to make sure that the taxonomy here also encompasses whatever RISC-V is doing. And I just don't know offhand which isolation model that they're using, or modules if there's multiple.
Sorry, I've been not following the.
Okay. All right.
Yeah, the RISC-V space.
Okay.
Recently,
all right.
So.
All right, because
if I can make a comment
go ahead, Robbie.
Yeah, hi. I was gonna just look at this document. This is the first time I'm joining this forum, by the way. So just want to say hi.
In that case, if you didn't already, please introduce yourself. We had introductions at the beginning, so go ahead.
Oh, sorry. Yeah, I couldn't join at for the first hour today. So I joined at 8 right before Dial's presentation started. So yeah, a quick intro and sorry for the interruption. So my name is Ravi Sahita. I work at Revos currently, and I'm also involved in the RISC-V trusted computing SIG. So I'm one of the chairs there. And so very interested to sort of work closely with the confidential computing SIG here or consortium here. In the past life, I have worked at Intel for a number of years and worked on confidential compute there. A lot of friends on this call, so I'm happy to see them again and work with them again. Yeah, and so I hope to contribute from the RISC-V perspective and the trusted computing SIG there. And to your specific question, that's actually one of the areas we are currently discussing in the trusted computing SIG there. Our goal is to functionally be able to support all of these different software workload models, right, that you were describing in this document from libraries to application containers and VMs, right? So just a quick short intro, but I'll definitely look at this document offline and provide more feedback on that.
Great, thanks Ravi for being here. I think we had
Thank you.
a presentation last month from other folks from the RISC-V consortium. So thank you for being here and hope you can continue coming to these meetings, and we appreciate any feedback that you can give us in the document. So
Thanks.
I was mostly looking to make sure that there's not some other variation that RISC-V is looking at that is not accommodated here, but to my knowledge, it should be so.
Yep.
All right, so let me go back to me sharing. Okay. So we've said the proposal is to have 3 entries in the isolation model category. And for the packaging model category, these are the terms that we had: confidential library, confidential process, confidential container, confidential VM, confidential application. We had lots of discussion about this. So I don't remember. Eric, where are we at on the confidential application term? Do you remember what's your understanding of our status?
Yeah, basically people last time didn't like the idea because it really isn't it's not a single packaging model. The issue is everybody had thought application was overloaded. I pulled it out, but I still think there's got to be some way of describing, let's say, multiple entities that are put together in a release. So I think we have a gap in trying to describe what's actually being protected when it spans potentially multiple libraries or multiple processes or multiple containers. And I don't have a term yet, but that's what we got out of the last go around is we don't really talk about how do we handle the networking and the integration and packaging of several things. And that's not yet done in any of our terminology.
I remember Mike had thrown out a term that they were using, which was like confidential workload or something like that. I don't remember, but I don't remember whether people like that or not.
But workload's still singular. And when you think about the user, they're going to want to say, I just want to install this app. And they don't care whether it's 2 or 3 processes as long as it works right. So I think that there is an open question of how do you handle things that are aggregations of multiple elements, including networking between the different processes that keep things hidden between them. And I think that's a very large area of work. We don't have to pick it up yet, but acknowledging that there's networked integration of these elements, which is a hard and important part, is key. Even in the picture, we have VM-based and process-based, and VM-based, it has issues. If you can get into the guest OS, you get all the processes. Process-based has, let's say, issues because you still have to pass stuff confidentially between processes. So we're not actually yet addressing the whole pie with our terminology.
Okay, so I'm not sure what to do about that, or if somebody wants to take an action item to talk about that as to what we do with the confidential application term. It sounds like that one is still one of the open issues. There's a bunch of text that needs to be updated that we kind of all have a common understanding on, that the text just doesn't match our common understanding yet. But I think that's one where our common understanding is still has some gaps in it, right?
I would agree.
I don't know how to get closure on it. I mean, Eric was absolutely right. When you talk about an application, that's a user term, and it spans everything from hello world up to Google search. And so everybody's got a reason why their application is unique and it's spread across multiple servers, et cetera. So I do think, something that's more tied to the hardware is something that's going to be appropriate for us to nail down, because then you can get to concrete definitions, right? When I spin up a process in Linux, that process may spin up multiple threads, and that may constitute one workload. The application itself obviously may span lots and lots and lots of functional work pieces.
So it occurs to me, I'm going to say something similar to, I think, what Simon Johnson, you said in a previous meeting. So I'm going to channel your style of a question here, which is, do we really need a term for this particular case, right? Or is this one that we can just say, whatever it is you're talking about, you say it uses confidential computing, rather than trying to define a term for it, right? And so the other ones, I think we have fairly strong understandings of what the terms are, but if we can't come up with what do we think something is, then maybe you just deal with it in text and not define a term for it. So that'd be kind of the fallback, is if we can't figure out what to use instead of confidential application, then we just don't define a term for that, and we just use it in context. Meaning you never use those two words together. You say, our application uses confidential computing, or whatever it is that you're talking about, Derek's point. If you have multiple things communicating, you find a way to phrase it in terms of, I do such and such by using confidential computing, and not define a term. You only need a term if you think there's going to be multiple similar things from different vendors or different projects that you want a common term to refer to the set, right? And if there really is so much heterogeneity, then maybe a common term doesn't make sense. So
I think that's also likely to be the case with container, because that was another thing that we couldn't really, there was no official definition of a container.
My recollection is I thought we had more consensus on that one, but you might be right.
On your original question, Dave, I think that we will need terms someday, but we're not there yet. Why?
Yeah.
Because somebody's going to say I have a confidential system because all the parts are confidential, and it's absolutely not confidential because they communicate over clear text. So at least we can punt it for now, knowing that there's a universe of user-facing stuff that still is to be determined.
All right, so we've got about 5 minutes left. And so let me just summarize what I think some of the next steps are. So what I have on the screen, this is that email from Mike that was the action item from last time, where he proposed two other things. It says, how does NARCS fit in there? And then what term were they using for, this does not fit into either of those two categories. It's not an isolation model or a packaging model. It's just another term that he's proposing here. So I want people to think about that one. Another thing that is not covered in the document right now, which we did talk about briefly last time, and not everybody was here. And Steve actually begged this in the Anjuna glossary discussion with confidential cloud, where part of the definition that Anjuna was using is a term that means that you have confidential computing and along with protection of data at rest and protection of data in flight. And if you have all three of those, then you have a blah. And here in his example, confidential cloud meant all three. It didn't mean confidential computing in the cloud. It meant that you're actually covering all three. And I've heard that type of request from others outside the CCC, is to say, well, confidential computing by itself doesn't mean anything. It's only when you have all three put together. Should we have a term that means all three put together, or do we not? So I want people to think about that one. And then for next time. And then there's some text edits that we want done. So Eric's got a new picture, so we want to put Eric's new picture in there. We've talked about isolation model of process-based and library-based and accommodating trust zone, where we want at least Thomas's help to make sure that the diagram can be correct. And just general edits to the document that match what we just summarized. So I think that's my list of everything that would need to be done, ideally before next meeting, or at least to continue the discussion at next meeting for the cases where that's needed. Is that a fair summary? Are there other major next steps that I've missed?
I'm good for the things that to do for next meeting.
That we're signing you up for? Yep. Okay. And I will make a pass and try to do some things like graveyarding my text that's obsolete and so on. So here, and anything that says that the same terms are used by two layers, this stuff will move to graveyard. So, all right. So to finish up, any other business? Brian, here's your time to talk about your announcement here.
Brian had to drop at the 30-minute mark.
Ah, okay. Ashley, do you have something? Is this something you can say anything about?
I'm actually unaware of this, but I'll ping Brian to send an email.
Okay. This is he filed an issue here, and we pasted it into the chat room and also bring it up on screen. He messaged me at the beginning of the call about this. He said, I filed this issue here in our repo. He says, we received an email a few days ago that the Google Summer of Code period for open source projects will be February 7th through 21st. I want to know if it's something that the CCC would like to participate in, or any of the projects would like to participate in. If so, you have to send in stuff before February 7th. We do have one other TAC meeting before then, and so we can put this question on there. But we want to make sure there's plenty of lead times. We want to get this announcement out there to all the projects and managers and stuff to say, if somebody wants to participate, there is a call for participation. So that's the announcement.
Yeah, Dave. Yeah, Dave, if I can.
Go ahead, Nick.
Yes. So the Anarchs project is really interesting participating in Google Summer of Codes. In fact, we have a proposal to help not just Anarchs, again, to participate, but all CCC projects. And I'll continue this conversation over GitHub, if that's okay. And I'd like to help here as much as possible.
Okay.
And
I'm going to put this on the agenda for next meeting then, and I can put your name and Brian's name by the agenda item if you want to lead the discussion next meeting about any updates and status and collecting information.
Yeah, I would very much appreciate that. Thank you so much.
Okay. All right. Got that, Ashley? Put that on the agenda for next time with Nick's name by it.
On it.
Okay.
Thank you,
with
Ashley.
that, next meeting, we have Verizon submitting, and we have Opti as Julian is talking about Opti at the Tech Talk next time. And we're still looking for things to go into February. And so we've got a couple possibilities, but that hasn't been slotted in yet. And so I know Hank has dropped, but I think late February, I think Hank is on later. But
I rejoined because my meeting was adjourned early.
Gotcha.
Yeah, but yeah, late February sounds like awesome to me at the moment.
Yeah. So that would be
Dave, if I may, is the 10th of February open?
Say again. Can you?
Is this 10th of February position open for the Tech Talk?
Correct, it is.
Would it be possible for me to talk about mentorship, and we can tie Google Summer of Code around that as well?
Yes, absolutely. Here was our list. Here's our queue, right? And so these are the top two on the queue is you, Nick, and Hank. And so these are the ones that we were just talking about sliding into February. So yes, we'll put this one here on Feb 10. And Hank, unless you tell me otherwise, I'm going to say February 24th.
I mean, the moment I'm recovering fine. So yeah, I think that should be possible.
Okay, because we got other things on the list in case somebody needs to swap out or whatever, but those are kind of the top two. So,
okay, thank you so much, Dave.
Great, and that takes us to the end of our meeting. Unless there's a last call for any other questions or any other business here before we close the call.
I have one amendment because it was just confirmed, but the Grameen webinar will be pushed to February 3rd. So I'll send a note and the registration will follow shortly.
Okay, thank you, Ashley. All right, with that, we'll go ahead and close the call. Thank you all for coming, and we'll see you next time.
Thanks, everyone.
All right.
Thank you. Bye-bye.
Bye all.